If you throw a ball upward, it follows a curved path due to the interaction between the centers of gravity of the ball and Earth. The centers of gravity are far apart, so this is action at a distance. The concept of a force field explains how Earth can exert a force on things without touching them. The ball is in contact with the field all the time. An electric field is a force field that surrounds an electric charge or group of charges. A gravitational force holds a satellite in orbit about a planet, and an electrical force holds an electron in orbit about a proton. The force that one charge exerts on another is the interaction between one charge and the electric field of the other. An electric field has both magnitude and direction. The magnitude can be measured by its effect on charges located in the field. Imagine a small positive test charge placed in an electric field. Where the force is greatest on the test charge, the field is strongest. Where the force on the test charge is weak, the field is small. The direction of an electric field at any point by convention is the direction of the electrical force on a small positive test charge. If the charge that sets up the field is positive, the field points away from that charge due to repulsion. If the charge that sets up the field is negative, the field points towards that charge due to attraction. Since an electric field has both magnitude and direction, it's a vector quantity and can be represented by vectors. A negatively charged particle is surrounded by vectors that point toward the particle. For a positively charged particle, the vectors point away. Magnitude of the field is indicated by the vector length. The electric field is greater where the vectors are longer. You can use electric field lines to represent an electric field. Where the lines are farther apart, the field is weaker. For an isolated charge, the lines extend to infinity. For two or more opposite charges, the lines emanate from a positive charge and terminate on a negative charge. Field lines are evenly spaced between two oppositely charged capacitor plates. You can demonstrate electric field patterns by suspending fine thread in an oil bath with charged conductors. The photos show patterns for equal and opposite charges, equal like charges, oppositely charged plates, oppositely charged cylinder and plate. Bits of thread suspended in an oil bath surrounding charged conductors line up end to end with the field lines. Oppositely charged parallel plates produce nearly parallel field lines between the plates, except near the ends, the field between the plates has a constant strength. There is no electric field inside a charged cylinder. The conductor shields the space from the field outside. When a car is struck by lightning, the occupant inside the car is completely safe. The electrons that shower down upon the car are mutually repelled and spread over the outer metal surface. It discharges when additional sparks jump to the ground. The electric fields inside the car practically cancel to zero. The absence of electric field within a conductor holding static charge is not an inability of an electric field to penetrate metals. Free electrons within the conductor can settle down and stop moving only when the electric field is zero. The charge is arranged to ensure a zero field within the material. Consider a charged metal sphere. Because of repulsion, electrons spread as far apart as possible, uniformly over the surface. A positive test charge located exactly in the middle of the sphere would feel no force. The net force on a test charge would be zero. The electric field is also zero. Complete cancellation will occur anywhere inside the sphere. If the conductor is not spherical, the charge distribution will not be uniform, but the electric field inside the conductor is zero. If there were an electric field inside a conductor, then free electrons inside the conductor would be set in motion. They would move to establish equilibrium, that is, all the electrons produce zero field inside the conductor. There is no way to shield gravity because gravity only attracts. Shielding electric fields, however, is quite simple. Surround yourself or whatever you wish to shield with a conducting surface. Put this surface in an electric field of whatever field strength. The free charges in the conducting surface will arrange on the surface of the conductor so that fields inside cancel. This metal line cover shields the internal electrical components from external electric fields. A metal cover shields a cable.